All right, here's a review for Unit 3. And let's go through this together here. So we have a parabola. We're looking for the vertex. Vertex is that lowest point right there. And so that vertex is at 3, -5. So the axis of symmetry is that vertical line that goes through there. And so that's at x equals, remember it's an equation here. So the equation is at x equals 3. The equation of the function will be y, we'll do in vertex form here, y equals x minus 3 squared, because it's moved right 3, and it's moved down 5. And the a value here, since this is the same form as y equals x squared, we'll always compare with y equals x squared, or compare to y equals x squared. And we know that y equals x squared goes through 0, 0, 1, 1, 2, 4, so on and so forth, like we talked about. Okay? All right, so here we have a vertex at, looks like -2, 1. So the axis of symmetry goes through that there, and so the axis of symmetry is at x equals, it's not a, at x equals -1. The equation here, now this one, notice this is going right 1 down 2, so it's going down 2. So that means our equation is going to be -2 times x. Now we're going left, so it's going to be plus 2 squared, and up 1 plus 1. That's where that comes from. All right. Now we got some equations we're going to graph here. So first thing, this is an intercept form. We don't necessarily need to go through in order here. We can't really tell the transformations yet. So at 6, the x-intercepts are at 6, 0, and at 2, 0, because 6 and 2 are the numbers that make the parentheses 0. So 6 and 2. Now, we can do the axis of symmetry. It would probably be the best thing to do next. The axis of symmetry goes right between those points we've learned, okay? And so that's at x equals 4. And we can find the vertex by plugging 4 into this equation. And so f of 4 here, let's find f of 4 is 0.5 times 4 minus 6 times 4 minus 2. And that's 0.5 times -2 times 2, which is going to be -2. So the vertex is at 4, -2. All right, the transformation, so let's graph that, 4, -2. There it is right there. Now, because this a value is a half, this is going to have vertical shrink. It's a little shorter. So this is vertical shrink. And because of that 0.5 there. And then it's moved, well, where's the vertex? The vertex is here, right 4, down 2. Always comparing it to the y equals x squared. Okay? All right, that's the idea there. Now we have vertex form. So this one we can look at and we can find the vertex. So the vertex is at -5 and +8. Because it's gone left 5, left 5 and up 8. And so the axis of symmetry is at x equals, don't forget the equation, x equals -5. And so this is flipped or reflected vertically because of the negative in front right here. So reflected over x-axis. And then it's left 5 and down, or up actually, up 8. Okay. So we're going left 5 and up 8. So it's going to be right about here. All right, our a value is -1. Okay, so we can find our other points here. Let's see. We can find them by going right. Oops, where's my point? There it is. We can go right 1, and we're going to go down 1 because a is -1. So we're going to go right 1, down 1. Right 2 from the vertex, right 2, down 4. And we'll end up down here. Always going from the vertex. Okay. I don't think I went far enough, did I? I didn't quite count 4. I think I only went down 3. That looks better. Okay, our axis of symmetry is in the middle. So we just reflect across that. All right. That's the idea. All right. On to the next page. All right, so we want a quadratic equation that has 2 positive x-intercepts. Well, since we're talking x-intercepts, we want to use intercept form. Okay, and this says use graph if needed. So the key is this. We have x. If we take some minus, now you can pick lots of numbers. Doesn't matter. Okay, so here the intercepts are at 2 and 7. The x-intercepts, that is. Okay, and that would be at 2, 0, because 2 makes it 0, and 7, 0. Okay. And, well, we don't have to graph it, but the vertex would be somewhere down here. I just approximated that. Okay. We'd have to plug in the axis of symmetry to find that exactly. All right, so for this one here, we can see what's going on here. We want to know what's greater, f of 3 or f of -3. Now, we could just plug it in, okay, but the key is this. The axis is at x equals -2 because it's moved left 2. Plus, this is in vertex form, x plus k squared minus, or h squared, sorry, plus k, and the a value is 1, okay? And so x equals -2. Now, so when we graph this here, the vertex is at -2, -3, something like this, okay? And so it's a pretty fat vertex. Okay, it's going to be something like this, something like this. So the question is, what's greater, f of 3 or f of -3? Well, f of 3 is going to be close to the axis of symmetry, actually -3, sorry. F of +3 is going to be way up here. Okay, so which is greater? Well, f of, let's see, +3 is greater. And the reason is because it's farther, it's going to be somewhere up here, it's farther from the axis of symmetry. All right, if you want to find those exactly, you can, and you'll find that out as well. Okay, so if we sketch a parabola here, that is a transformation of the parent function that's moving 3 to the left and up 4. All right, so we want to come up with an equation of that. So that would be y equals x minus 3 squared, actually plus 3 because it's left, and then up 4. and reflected vertically, so it's going to be negative. So left 3, up 4, and so there's our axis of symmetry. And what else did it say here? Oh, reflected vertically. So it's reflected vertically. Okay, no vertical stretch. Okay, so we're going to go run the vertex, right 1, down 1, and there's a new point. Then right 2, down 4. 2 squared is 4. And then copy on this side of the axis of symmetry. Copy that. And there's our parabola there. All right. So that's our equation. Okay, a couple more here. We've got intercept form. We've got some x-intercepts. So remember, the x-intercept is when this is 0. So what makes this 0? And we've got x minus 5 and x plus 6. And what makes those 0? Well, what makes the first one 0 is x equals 5. That makes this first factor 0. Second factor is x equals negative 6. Now for the y-intercept, we want to set x equal to 0. So we need f of 0. And we're going to do 0 minus 5 and 0 plus 6. And negative 5 and 6 gives us negative 30. So the y-intercept is y equals negative 30. Way down there. All right. Then last one here, which one of these are equivalent? Good little question here. All right. Well, we got standard form. And so standard form, we can see if it's equivalent by distributing here. So if we distribute this, or we can factor, either way. Well, let's go ahead and factor. Let's practice factoring. Looking for two numbers that multiply to 15 and add to 8. So I think we're looking at 3 and 5, but they're going to be positive, right? So that factors to x plus 3 and x plus 5. That is definitely not the same as this one because of the minuses. So the f and g are not the same. What about this one here? Well, we could graph it and find out if we go left 4 and down 1. That's I'm sorry, right 4. Shame on me. 1, 2, 3, 4, and down 1. There we go. And then we're going to get this parabola that opens up because the a value is 1. And it is going to have intercepts at 3 and 5. Now you can check that out. X equals 3 and x equals 5 are the intercepts. If you plug in 3 here, we get 3 minus 4 squared, which is negative 1 squared, which is 1 minus 1, which is 0. So if you plug in 3, you get 0. If you plug in 5, you're going to get into h of 5. We're going to get 5 minus 4 squared, which is 1 squared, which is 1 minus 1, which is 0. So you can see that yes, okay, these are the intercepts of this as well, the x-intercepts. So the moral of the story is g and h are equivalent. So g of x is the same as h of x. Okay. And there you have it. All right, hope that helps. Get those forms down and you'll do well.